Welcome to the companion video to the controller video for the robotics course. This is the physical work component. So adding on to what we learned about basic controllers and Arduino, the basic work with the simulator and some of the language coding, this will now show examples with working with a physical Arduino Uno, here specifically the Free Nova version of the Uno that we have here. So in this one, I'm going to go through actually going to Arduino and downloading the IDE and installing it, which comes with all the libraries, the base libraries, and examples, and the compiler that's actually needed, and then get up to working with the program and adding maybe a few extra things to your language skills. So why it's useful to watch all three videos. Please don't just watch this video. Please also watch the simulator video and the main video. Okay, so you can see I have got the Arduino board plugged in, and this is the first time I'm plugging it in, and you can see some of the little LEDs blinking, which is the starting program. That's just built into it until we start doing more with it. I shall unplug it for now so it doesn't affect anything. So I'm just unplugging the USB cable from my computer, and we will just set to that to the side. And I'll shrink down so we can do a little bit of work on the actual computer itself. So first step, just go to the main Arduino website. So whatever search engine you want, Arduino, and you can go for the language reference, everything else, but you can just quickly jump to the download section. And now they do have an online code editor you can play with, but for right now I'm going to work with the desktop mode so we don't have to worry about any other weird compatibility issues. So from here, just install based upon your version of your system. Here you don't have to donate, but again, they're an open source one, so if you want to, you can one time. This is a course in your students, so don't worry about that. You don't have to pay to get anything. This is all free software. The money just goes to actually help the community in their building and what they've done with this open source development. Okay. So you've got your installer, and we'll just go through the steps of the installer, like everything else. Move this up here. I agree. Here, just install everything else you needed. So the USB driver for connecting, start menu, desktop, you can decide what you want to do with those. Here it's definitely good to leave the associate.ini files. When Arduino saves any of its work you're doing, or even if you're working the simulator and you download the code, it saves into a directory that matches your project, and it makes a .ini file. Wherever you so choose. Installing Arduino. You probably want to speed through this since you are in a video. You can step further, but I'm gonna keep singing the Arduino. Installing. So slow. Boop. It is asking me to install this. I will just say yes, because this deals with ports and comms and everything else. And this is additional with Adafruit stuff, so if you buy Adafruit things in the future, it's just good to do this earlier on So you have the drivers and everything that is needed. Same as the rest of them. Install. And it's going to keep asking me these for a bunch. Okay, so we're done. Close that. We don't need the web browser anymore. And I will just move this up here. Is that Adreno have the nice little startup. So the next thing we can do is just to open up the actual IDE. Okay. Normally it'll just pop up for you. I have it popping up on a different window. And here you go. Very basic IDE. Since again, the community of who they're trying to go for. You can probably get plugins for other more complex IDEs if you want to develop in that environment, but I suggest just sticking with this very basic one. So it'll open up for right now to a default program that you can start writing. You have your sketch, your first one, which is what these programs are called in Adreno, and then you can start adding more files and whatnot, but we'll stick with just one file for right now. I suggest going through other tutorials and getting familiar with this. There's a lot of extra stuff that you get. There's a ton of examples that are built in when you download this, so very basic ones. So this will load the code, but you still need to go to the Adreno website and their tutorials to see the actual wiring diagrams and how to hook it up or read these. But it's a whole bunch of different cases of how to do stuff, everything else with other types of devices and servos and all that fun stuff. Your preferences and editing else and these actual tools itself. So we've got the editor open and we want to go in and start doing something with the code. Now I'm going to bring this up full screen for right now, and what we're going to do first is I'm going to go back to just like we did in the simulator and just use the Adreno as a power source. Not do any coding or anything else with it yet. Just get it to actually just turn on an actual light. And so for right now, being the steps, remember you want to have everything like unplugged when you're working with it, is that you don't want any live power or anything going on. Now normally what you could do for this is either unplug it from your computer, I'll plug it back in, but just to make it easier is I'm just going to always keep unplugging it directly from this. This won't harm the machine to suddenly kill the power. This is kind of what they're designed for with Adreno, so I am just going to pull it out from my connector there, have no power, and I'll do my work with it and reconnect this in when I'm doing anything else, which hopefully won't disconnect anything as I'm doing the work. So you always want to do this because, again, you can have it on and be changing stuff, but say if you get some static shock or anything else that comes in there that you can have having problems, a short that could destroy things. Not hurt you, but still. We'll start with this. I have already set up a breadboard similar to we started to last time. You don't need to do the same thing. I have 4 lights because I just want to do something different later on. So I have it set up with that basic kind of setup just for controlling a light. So 1 LED. You can pull it out and see from right here, the longer end and shorter end is that I have, it's the anode here and the other side is the cathode. So the short side. I'm putting it into the boards. I have cut the leads and all my resistors to be shorter. I would not suggest doing this yourself. I know I don't need them again, and I just didn't want huge wires sticking up, so I just cut the metal on each side a little bit shorter and shoved them in, so I kept a little bit longer part of the lead, just made them shorter. So you have right here, and I'm now having on the cathode going again to what I plan to be for ground, and I'm leaving the anode open to connect for power. Boom. So we have it right here. So first step is I want to connect the ground itself. So off of the actual Adreno. So getting my jumper cable with the M prong end. And on the Adreno itself, again, you're looking for the power section or anything that says ground or GND. So you can see over here, I've got my power and I've got ground. I've also got ground over here on this side, but I'm just going to stick with the ones over here. It's arbitrary. Now, when you're doing this, this is where it gets kind of annoying to read these, depending on where it is you want to really make sure that you've got it lined up and not plugged into the wrong pin. Because sometimes it happens where you put it in, you thought with your eyes you got into 10, and you got into 11 instead. So we've got ground, and we've got ground. So I'm plugging into ground there. Just getting it in, don't have to go too far. And then anywhere along my right here, I can plug this in. So I'm gonna move that over just so we're a little bit further out of the way. Really doesn't matter as long as it's along that same row and we're using this outside because that rail then is connected. So now we have ground connected for all of the actual resistors that then are connected to each of the cathodes separately, and these are all separate. So the idea is in the future this will be 4 separate circuits, and we're just going to hook up one circuit right now. So even though this is connected here, this circuit is open because the anodes won't be connected to anything, so that won't do anything. We're just going to complete the one circuit on this other side. So now for power, you want to get another jumper cable, and I'm sticking again the keep convention of black for negative and red for power. So, and we're putting it into the 5 volt. So just like in the simulator video and everything else pointed out where we had the power, is that I just have 5 volt right here, plugging that in, and I'm going to put it on the actual power rail for now because we're going to be sharing that power throughout. And then after this, gonna take, I'll get a, yeah, handy dandy. So I'm just doing this so we can share this later on. Actually, no, it doesn't matter. Doing it here is I will just directly connect it over here because I'm not using it for any of these for later on. So right now I'm completing and making a complete circuit for everything that's right here. So all of these are open circuits. This is your closed circuit, being that it'll go from the 5 volt once we give it power, go through here, go up this row, through the anode, down through the cathode, back through the resistor, and then all the way over to here for the negative, and back in for the actual ground. So completing our actual circuit. So now I'm ready to go with this. I'm just holding this down, making sure I'm not touching any metal parts, and I will just get that power in. And there you go. So the Arduino program that's on the controller is running, but again, we are not actually, like, we're not worrying about that. We're just using it for power, which is like quite hard with how bright I got my lights here to see that there's any difference from there. So let's see if I can change this on to make it at least a little bit darker in here. Bah. Turn that off. And I think we don't even need the other lights for the rest of this video. So make it easier since we're working with lights. Now you can see, hey, the blue light's on. We are good. I'll do something you probably shouldn't do, but we're lower voltages. I'll just even move this over to test with the red light. Okay, red light circuit is on. Yellow and green does work as well. Now, normally, as I say again, I don't suggest actually doing this yourself, as you connect it off with power so there's no other issues, but hey, we're doing it live. So just testing. So again, this was now just using the Arduino for nothing special other than the power pins that it provides do some work. So basically treating it like a battery itself and getting work done. But we want to do something more interesting with this, and we want to start coding with it and start controlling that. We can do something with that light. Right now, based on what we've learned in the simulator video, is just being able to turn it on and off. Nothing about fading or changing the brightness or anything like that, just on and off. So next thing, I want to rewire this. So again, normal procedure is disconnect everything from your power. So unplug it from there. And now we want to be that, well, we leave the ground is always going to go to G and D for the end negative terminal. But now to control the power from the pin that we are actually working on, the LED, we are going to use one of the GPIO pins now, which will be then used to indicate that we have power or not going to it. So when you're looking at the Arduino board again itself, is you have all the pins on each side here where you can plug stuff in, and they're labeled. We've got analog, you stay away from those right now. You've got power. Then over here you've got all of your digital pins, and the digital pins are used again to like for basically on off for right now. Later on we'll get into something a little bit differently for controlling it. So we want to pick basically any one of the pins that's on this outside, staying away from the 0 and 1 for right now. Doesn't fully matter, and I will just go with a different one than we did in the simulator video. I will go with pin 12. So I'm just trying to line that up, going pin 12 going in, and then we're hooking it up to the row so it goes to the actual anode. Now, if I was to plug this in, nothing's going to happen. We don't have a program loaded. We've done nothing else with this. So we will just go back. I'll check this down, and now we will go to do some more code work, leaving a little video down there. So making this easier to see, should have done this earlier on, is I'll just increase the, become obnoxious for this video, and I'll just make it huge font so it is really easy to see. Okay, so we have our startup. You've got your loop function that were all explained in the video, and again, fully more explained in the simulator, and the syntax for everything else was also explained in the simulator video, so I would still suggest going and watching the simulator video first before you go to this one. Now, when working with the pins, as I said, I suggest that you start making constants in the beginning to keep track of what you have connected to a pin, so what pin it's on, and you give it a good name that describes what it's connected to. Just makes it easier between the code. So const int LED_1. Making use. So that's the first LED. I'm even going to say, yeah, let's do LED 1 for right now. We can see it's blue, we can see it's whatever, and we can just confirm that, okay, well, whatever we put this to, we have to make sure it matches up to what we have in here, and we have it connected to, boom, pin 12. Yeah. So pin 12, so this doesn't, putting 12 there doesn't make it say that this is connected to pin 12 yet. It just means, okay, that's the number I'm using, and I'm saving it into this variable. I have to actually tell the Arduino board that I'm going to be using pin 12, especially for doing output. So the 12 really is just me putting a constant number. This does not say that this is connected to that pin yet. It's not until we start using the functions and tell the function, hey, give it the number 12 that we're working with that pin. So first step, you have pin mode, explained in the simulator video, LED_1, setting it for output. Boom. Next, in the loop code, we're just going to do a very basic blink like we did last time, where you have it on, then delay for a bit to leave it on for a bit, then off and delay for a bit before we go back on. So remember, that's the digital right. And LED_1, telling it what pin that we want to send it out to, and going high to say that we turn that pin on. Then delay. Gonna do half a second for right now. Right. Oh, that tells me I did something wrong up here. There we go. Didn't even notice I did that wrong because it was not that I spelt that wrong for the first function. Fixed it because now I can see that it's color coding it properly. So LED_1. Boom. Low. And do another half a second delay in between. And now to be even kind of, that's a little bit more fun, we can say, well, okay, int delay wait. Ooh. I will make a constant for the delay that we're working with. Just so it's not even hard-coded here. So if we want to change it later on, we can just change that one constant. Boom. Okay. So we've got the LED 1, say pin 12. We got the pin mode on. We've got the digital write and the delays. And now remembering that when we first power on the Arduino, these variables are going to be created in that RAM, the flash memory for it, for running the program. You're then going to get the setup function to run, which will then run the pin mode, telling the controller that, hey, pin 12, because that's the value that's in this variable, we're setting that pin to output. So to be able to send signals out on it. And then within the loop function, which will run after that, it's going to go turn it on, the highest value. You're going to have delay, which again, I spelled wrong. And then digital write, and then delay again. And remember when it reaches this bottom, it just goes back up to the top for right here, and then continues the rest of it. So it'll just continuously blink forever until we disconnect power from it or restart it from there. Now, before going on, you'd always want to check your code to make sure that everything's okay. And that's where you get the buttons that are up here at the top. You got verify, which will just compile the code and will check that it's good. And then you actually have upload, which will compile the code. And then if everything's okay, it will then upload it to the actual device. Because remember, when you're compiling it, you're not running it on the computer that you're developing it on. You are then moving it over to the device, which becomes the fun of doing a lot of your development here. And fun, I mean, and slightly sarcastic, is that as you make changes, you have to upload it to the device every single time and restart everything and not make the changes. So you'll code, you'll upload it and restart everything and make sure that everything is working properly. So before I connect the actual Arduino to anything, I'm just going to show examples of verifying it, which is just compiling. Now it goes through doing this. First time for me because I haven't saved it. It's asking me to actually save it. So I'll save it onto my desktop. Example. Save. So when you make the project itself, I'm just making sure where it suddenly popped to for me. Okay, I'll come back to that. So it saves it into the directory wherever you want and gives the name, and it has that .ini file. Okay, either way. So I got here, and now it's not going to be noticeable what's happening, but you have to look to the bottom of the actual screen. This is kind of the actual output you're getting. So it says done compiling. There's nothing popping up for here for errors. And it says sketch uses 934 bytes, so 2% of program storage, and saying what your max is here. So this is compiled. Nothing's been loaded because I was just verifying. We had no errors. And what this information is saying here is that, well, this is how much physical space the program's taking after being compiled. And as I mentioned, when you're dealing with controllers, like the microcontrollers, you have limited memory for the actual programs. So here we're okay. We've only taken up 2%, but that's all the basic things they have built in and my little bit of code here. And you want to verify that that's okay. All of our basic programs will have no problems. Next, I'm just going to show you an example of an error. So we'll go back to as if I spelt something wrong there. So DILA, which is not highlighting as any kind of built-in keyword, and it should complain. So there you go. Here it's highlighting where it's gone wrong and trying to give you some kind of message. It's not always the best. So DILA was not declared. It doesn't know about any function or anything like that. So usual. So you go to delay, and we want to actually verify it. Hey, it's working. So if we're ready to do this now this is where we go back, and if we bring up the circuit board, is that we want to connect this now, the USB cable that's plugged into the actual computer. We want to plug in our Arduino. So I've got the wiring done. There's no power. I'm ready just to upload the actual code. So boom. Plug in my USB cable, which will connect it to the actual computer itself. So we've got here, you can see the button. So it's just running right now. There's no code on it. It's running whatever program was stored onto the controller chip here before. We'll go back to the actual program here. Move this over just so I can have the code open, and then I can bring up the side window and we can see some flashing lights. Maybe even move the camera just a little bit closer if I possibly can. Bear with me as I change my little camera rig here. Okay. So we've got that. So the first time you plug in your Arduino, you want to make sure everything for your sketch and everything is set up properly. You don't have to keep doing this, but it's something to check if something's going wrong with uploading. So this is where you want to go to Tools first, and then you want to select Board. Now by default it's saying like Arduino Uno, because detected that, so you're okay. So I'm just verifying, hey, it says Uno. Next is to know what port it's actually connected to. And make sure here. So this is not letting me select it, so I'm hoping that everything is actually okay. Okay, so we'll just try. And so now if I've got all of this, normally you'd have to go and select the actual port from it. So still saying Arduino, still saying what we have for the actual port. And now I will try to actually upload it, and hopefully everything goes right and doesn't blow up in my face. So it's compiling it, and here now it's complaining to me is that serial port is not selected. So it can't find the actual Arduino device that we're working with, which happens sometimes. Let's hope and see that if I can actually diagnose this properly. And I don't know why. Okay, sorry for that little hiccup. I should have tested a few things on my own machine, but this is a good thing to discover for people who are using the Blackboards, is that if you have the blue version of the FreeNode, you are perfectly okay, but depending upon your configuration with the FreeNode, it may not actually install the driver the first time. What I had to do was download the full tutorial kit zip. This is on the Google Drive, or if you go to the FreeNode website, and I had to go under drivers, and then for the version of what I'm working on was Windows, and I had to run this program here to install the actual driver to be able to communicate with this board. So if you got the black version of this and it's giving you issues, the first thing again is to install the proper driver, which comes with a zip file that you can download for this. If you have any issues, please reach out to me. So once that was all done, I just had to open and close the Arduino program again, and now I get where I've got the board selected, and I can see port, and you can see where it says COM5. Really, you should see the Uno or others. There shouldn't be much else that's common here, and you have to select the right one to say, well, that's the USB port that is communicating over serially to actually upload the code. So now if I click upload after all that, so again, tools, making sure it's board, making sure it's COM, that's the first time, and now I can go click upload. And you will get, now that it did do everything. So we are good. I upload the program, did everything from right here. Now, one key thing to look for is that when I upload this, you want to watch the little lights that are right here where my fingers are pointing. So I will even turn off, like, change the lights to make it a little bit dimmer in here so it's a little bit more noticeable. You'll see one light flashing, but where my lights are, the TRTX, is that when I'm uploading that, see in the code, you will see that they blink a lot, and that means that it's transferring the program over. And what you can actually see now is that our code is running. Like, there we go. Even if I make this like full screen from right here, you can see that the code that we wrote is now controlling, and it's continuously just turning on and off that Arduino, the LED. I'll shrink that back down. So we can go in and we make changes. So right now it's just going to always continuously keep running that program. If I want to restart the program without unplugging it, there's this little red button down here. This is the reset button, and if you press that, Basically, the Arduino turns off, restarts itself, and reloads the program and starts from the very beginning. So it's like a little quick fix. So if we come here and do, say, another quick change, so I'm going to say change it to 100 milliseconds. Now, to get to work, I can change that, but I've got to upload it to the actual board and then get it to start running the program again. And there you go. Now you can see just... But I'm going to go back to the 500 for right now, but I also want to show something else. If we did not have the delays now, which was in the actual simulator was hard to notice, what would happen? So if I remove those delays and it's going high and low, and now I upload it, you can see it just looks like the LED is just on. Right here, it's not turning off. But the idea is it is turning on and off. It's just so fast that your eye doesn't see it. Even the camera here is not picking it up. And like you don't see it because then you have to have that delay because the machine is running so fast. You won't see anything. This is why you're adding in that artificial delay just so that you can communicate it back to the actual user, part of like your actual interface. So these things will become important. Okay. So right now this just means I'm going to upload the new code to it. So it's just blinking every half a second. And there we go. So I've uploaded the code, but let's say like I don't want this to always be running from the computer. So I'm plugged into the computer here for my power, but what if I don't want to actually do that? Well, I'll deal with that at a different time. You can then run it off of other things. So say, let's run it off 9 volts. So I'm going to just pull out the power source that's right here. I'm going to bring in the 9 volt that we've used before that's connected to the barrel jack connector for right now. And then now instead is, well, I've loaded my program on here. So my Arduino has the program I've loaded. It's stored on the actual chip that's right here. And now instead I can then plug in the battery into the barrel jack connector. Now as soon as I plug that in, the whole board will get power and our program will start running that we loaded there. So now this is running independently. So we used our computer to code, we used it to compile and upload onto the controller chip itself. And now after this point in time, it'll just always keep running our blinky program forever and ever until this battery source dies. Okay. So unplug that, and we'll just do a little bit more work, extra learning this week. So plugged back into the computer. Now I want to add in a little bit more skills for how you write functions, and then use that to play around a little bit more with the boards itself. So we'll leave this here. I'm just going to go to code. And so now we want to make a new function. So I'm going to start adding some stuff in just to make my code readable. A nice practice I like to use is separate all my function with little commented out lines so things are easier to see and find. I'm going to start writing some useful functions below. So again, the lines are just to break up the code, make things easier to see as we're going. I'm going to add a new function now. Okay, well I want a function that I'll just call to do delay. So I know that this code that we have in the loop right now is that given a pin and a delay time will delay for a specific amount. So let's make a generic function that will delay 1 light. So this one I want to write function. It doesn't need to return anything, so I'm going to give it a return type of void. I then start writing the name I want to call, blink LED. And then just my conventions of opening and closing curly brackets, and we have the brackets to indicate where we want parameters. Now in this case, I want to be able to indicate what LED I want to blink, and I also want to be able to indicate what specific delay time to actually use for that blink. So here in the first parameter, I'll go int. I need to specify the type. So again, for the Python individuals who are in the course, you can't just put a name of the parameter. You need to specify the type of information that you can use that's going to be stored. So I know that, well, it's going to be a pin number, which is just an integer. So We'll just say pin to make it descriptive as the name, and then int wait underscore time for how much time we want it to delay. I will now take the code that we have up here and make it more generic. So digital write. Change the variable we had before, so we're using the parameter instead, and then change the delay. Okay, so we've got this. I like to verify as I go, make sure I got no weird errors, and then now I'm going to start calling the function. So I'll test it just quickly first to make sure that it works with our original one, and then we'll start adding some new stuff. And then the wait time, delay wait. Add my semicolon. So basically doing the same thing we did before, but now we have a function that we can reuse again in multiple different ways. So I'm going to upload this to the board. Should be okay. And there we go. We got our little blinking light going for us. So nothing too fanciful. Now what we'll do instead is now we're going to have a little bit of fun. Let's get a bunch of lights blinking and play around with this. So I have the other 3 LEDs that I've hooked up now. So I'll do my coding. So I'll disconnect from the power source that we have there, and now I'll start connecting the other LEDs in, so that we have right now one pin that's used for the LED 1, and we'll call this LED 2, LED 3, LED 4. So I don't know, just for fun, let's even get the matching like color cables that match to the color of the LED, and getting ones that are long enough. Okay. So I will get one that's for the red LED, and the idea is we just need to use another open GPIO pin. So I'm going to put it right next to the blue one, which should be pin 11. Doesn't really matter for right now because it doesn't go in from right here. We will then get a yellow cable and connect that for the yellow LED, always making sure it's on the anode. Connect it down to here. That should be pin 10. And then finally we will get one for the green. That's hopefully I have a longer one. Ooh, that's much longer. Good enough. So we will get the green, and you can see the fun of doing this as everything starts disconnecting while I hit stuff. Yeah. Oop. And green right next to that one after it. So if we follow that, blue is in pin 12, red should be in pin 11, the yellow should be in pin 10, and then green should be in pin 11. Oop, pin 9. I'll just take a look and confirm myself. The fun for everything else. Okay. Okay. Got all of those in there. And then me confirming. Yeah. Okay. All the cables, just using the color so it makes it easier to follow. You can see how things start getting a little bit crazy as we go. So I've hooked those up. I want to do the rest of my coding before I do everything else. So I will then change these around. So LED 2, LED 3, LED 4. Let's even make it better. Blue, red, blue, red, yellow, green. To make it even easier to remember in our code what's connected to what. So pin 11, pin 10, pin 9. We now then need to go change all the pin modes here. So blue, let's copy this one and change it over. set them all for output. Green. And now we've got our blinking here, and we will just get them to all blink roughly at the same rate. Now this won't be perfect because it's going to blink the first one, and then the next one, then the next one, and then the next one. So they're not going to all be blinking at the same time using these functions that we have here, because the idea is that the first one goes high and then goes low, and then waits, and then this one will go high, then low, then this one will go high, then low, then this one will go high, then low. If you want them to all blink at the same time, you need to modify these functions so that it does, it'll do them all at the same time. So you do the digital writes all at the same time, the delay, and then the digital writes for the low all at the same time. But here I'm going to have them blink one at a time, so it looks like it's going in a row. Just for example, and I should probably change that so it's actually going red, yellow, green. Okay, let's verify that our code is working. Yep, and then now let's actually upload this and see if everything works in the first try. Okay, in this, oh, here's the best part. I forgot to plug it in. Bop, 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 bop. So now I should be able to upload it. And there you go. Magical. Yeah. Blue, on, off, red, on, off, yellow, on, off, green, on, off. So going back and forth. And so you can basically see here, this is the top of the loop. And as we get down to the bottom of the loop, and then it goes right back to the very top. So that blink function works to blink them individually. Again, if you wanted to blink them all at the same time, you'd have to modify them that they all go high, then there's one delay, then they all go low, and then there's one delay. But this is what you want to play around with. See what you can start building and doing. As magical as just controlling 4 lights is, and you can see even just doing these 4 lights already took 4 pins, and we have limited space, and we have enough, we're adding more load to the overall device, and so forth from there. So I suggest from now that you guys keep playing around with this, get a little bit comfortable, work on the actual task as it's posted, and continue to be great people.